This is Note-Taking Guide 2.9. We're talking about the fundamental theorem of algebra today. What it says is if you know the highest power or degree of your polynomial, you also know how many answers you're going to have or how many roots. Okay, so roots is just another way of saying answers or solutions. So if my highest power is 3, which is called my degree, then I have a chance of having 3 real roots or 1 real and 2 complex roots. You can read through this chart to understand it a little bit better, but I'm going to jump down and do these problems. Okay, the problems say find the degree and state how many roots they have. Well, the degree is the highest power, so in this case the degree is 4. And then it says how many, or what are my different kinds of solutions I can have. Well, if I go up and I look at my table up there, it says I can have 4 real roots, or I could have 2 real and 2 complex, or I could have 4 complex solutions. So I'm really just using my chart up above to answer the questions. Okay. All right, let's go to the next problem. The degree is 2 because it's the highest power. And then what I'm going to do is I'm going to go back up to my chart and see what kinds of solutions I could have. I could have 2 real, or I could have 2 complex. Those are my only choices. This last one, when I'm looking for the power, I'm going to look at that power on the x, and the power is 1, so my degree equals 1. And how many solutions can I have? I can only have 1 real solution. This next little part right here talks about what the graphs of quadratics should look like. And it looks like I might have, let me see here. If my quadratic equation or my graph touches in 2 different places, then I have 2 real roots. Quadratics are a degree of 2, so all of these graphs that we're looking at today have a degree of 2. 2 real roots if we touch the x-axis in 2 places. Now it looks like we only have 1 real root here, but we really actually have 2 real roots. When our graph touches the x-axis and doesn't cross this, it's when we have something like x minus 2 times x minus 2. It's the same number twice. So I'm going to just put same number, and we're just going to remember that every time it touches like that, we're going to have the same number 2 times. When our graph doesn't touch the x-axis at all, we don't have any real solutions. We have 2 complex solutions. So looking at a graph, we can determine what kinds of solutions it has by seeing whether or not it touches or crosses the x-axis. Now, if we want to look at the equation, we're going to have to do something called the discriminant. The discriminant is part of our equation where we do b squared minus 4ac. And b squared minus 4ac, if it's greater than 0, which is what it says up here, then we have 2 real solutions. If it's equal to 0, we have 1 real solution is what this says, but I don't really think that that's a great way to say it. We already said up there at the top that if we have a degree of 2, we have to have 2 solutions. So 2 real solutions, but I'm just going to put hashtag, or in this case, the number sign. The numbers are the same. Okay, and then if you're less than 0, then you have 2 complex numbers. So I've had a lot of kids really struggle with this today, so I just want to make you know that if your number's negative when you solve your equation, you're complex. If your number's positive when you solve your equation, then your answers are 2 real. If it's set equal to 0, if your answer is 0, then you have 2 of the same solution. So let's just try these really fast and see what we're talking about. So what I have to do is I have to solve the equation b squared minus 4ac in order to figure out if I have 2 real solutions, 2 imaginary solutions, or 2 real that are the same number. My a comes from the number in front here, which would be negative 2. My b comes from my x term, and my c comes from my constant term right here. So when I substitute in, b is negative 4, so I'm going to have negative 4 squared minus 4 times negative 2 times 3. Negative 4 squared is 16. Then negative 4 times negative 2 times 3 is a positive 24. That adds to be 40. So I'm going to go back and I'm going to look at my chart here. I see that my number is positive because b squared minus 4ac was greater than 0. So I have 2 real solutions. So that's my answer for today. 2 real solutions. Okay. Let's look at the next one. The next one is a graph right here. We are just going to look to see if it crosses or touches the x-axis. And right here I actually have 2 points that it does that at. When I have 2 points that my graph touches or crosses the x-axis on, I have 2 real solutions. And I can find that again by looking back at my chart. All right, the next one is an equation. Again, I have to identify my a, my b, and my c. My a comes from in front of the x squared term, which is 1. My b comes from in front of the linear term, the power of 1 term, which would be the number in front of that, which would be 2. And then my c comes from the constant, which is 12. I'm going to do b squared minus 4ac, and I'm just going to solve it really fast to see what kind of number I have. B squared would be 2 squared minus 4 times a times c. We have 4 minus 48, which would be a negative 44. When I go back and I look at my chart, if I have a negative solution, I have 2 complex numbers. So my answer here is going to be 2 complex. Looking at the graph again here, my graph touches or crosses the x-axis in 1 point. When that happens, I have 2 real solutions, but they are the same number. So I'm going to do same number there, or numbers are the same. This next graph right here, when I'm looking at my x-axis here, it doesn't touch or cross my x-axis at all. Because it doesn't touch or cross, I know that I have complex solutions, 2 of them, because it's a quadratic. Last problem here. Last problem is right here. I need to do b squared minus 4ac. My a is 1, my b is 4, my c is 4. So b squared would be 4 squared minus 4 times 1 times 4. 4 squared is 16. Negative 4 times 1 times 4 would be a negative 16. 16 minus 16 is 0. And if you go back and look at your chart again, if you find where your b squared minus 4ac is equal to 0, it tells you that you have 2 real solutions, but those real solutions are the same number.